welcome back. In case you tried to join the class last week later in the time period and you saw the meeting was closed, don't worry, you didn't miss a class. Did not hold one last week. So we are currently on week 2 of our CAD 2 class. So 2 weeks ago, we had our introduction. We went over some basic Onshape review. I know some of you, not everyone's here right now, but I know some people that week didn't have Onshape, but hopefully by now you've all been able to get Onshape, get your account set up, and have been able to go through the steps to creating the chess rook.
I didn't do that.
So in the first few minutes, I'll just get started up. Every week when we start the class, I want you to just, even if I don't say anything, start up Onshape, log in, make sure you have it open because we're going to be using it every class. So if you have any questions about the rook that you didn't get to ask last week or that you had in between then and now, feel free to ask.
I wasn't here the week you did the chess piece.
All right. If there are no questions, then there is one other announcement.
I have a question.
That is to join the Google Classroom.
I have a question.
So I know a lot of you are already in it. If you're in the session from the one immediately before this one, the CAD 1 class took place from, I guess, January to March this year, then you might already be inside of it, but make sure that you have access to this Google Classroom and that you join it, because starting now, I will be posting the slides each week. So in case you need to look at the slides again, they'll be posted here. And later on, when I have like homework assignments or other files that I want you to look at, I'll usually be putting the files here so that you can all access them. Henry, do you have a question?
So basically, I think you didn't.
Oh, sorry, I couldn't hear you. Could you? I was muted. The computer was muted. So can you say that again?
So basically, I didn't do the chess piece because I wasn't there.
Okay. Yeah, that's fine. You have experience with Onshape, right?
I was in the first one.
Right. Yeah. Sorry, it's hard for me to remember all these things, but yeah, I remember now. So when you have time, maybe between this class and next week, just take some time to like try making this yourself. You don't necessarily need to like watch the class or anything. If you think you have the knowledge to know how to do it, then yeah, I would say try it out just for the practice, because that's really what it was for, is just to practice and get everyone on the same page with the basic tools. All right, so in the chat, for those of you who just joined, I'll put it in there one more time, but please join the Google Classroom with this code, because like I said, I'll be putting the slides here and I'll be putting things like homework or files that you need here as well. So just make sure that you have access to this at the very least before next class. And because the homework for this week will be something from the slides. Okay, great. Now that some more of us are here, I'll start talking about our new topic for today. And this is something that we're going to be relying on pretty much for the rest of the class. It's very important, and it's the concept of our engineering drawings here. So typically when we think about a drawing, I'm sure you've all done drawings before, maybe at school, maybe for your own enjoyment. We're trying to represent something in real life on a piece of paper, right? You might draw a picture of a tree, then what's happening is there's a tree in real life. You are looking at the tree and you're trying to represent symbolically somehow the idea of this tree, this 3D real object, a tree, on a piece of paper. So it's pretty much the same idea for what we call engineering drawings or technical drawings. We have a 3D model, right? And maybe it's even an object in real life. let's say that I have this chess rook, and I'm trying to convey all of the information that's in that 3D model or that real life object onto a piece of paper. So there's a bit of terminology, there's a few ideas that I want to communicate about these drawings. And we're going to do a bit of practice. And where we're going to go from here is, from now on, whenever I ask you to model something, up till now, we've just looked at a picture of it and just kind of free-handed it, right? We didn't actually know what all these numbers were. We didn't know the exact proportions to make things. We just drew the basic picture with lines, and then we made up some numbers, right? Like, these numbers aren't corresponding to any real chess piece that I have. I just type the number in because I can. So that's kind of where we're moving ahead from now. Now we're going to be getting the numbers, the proportions, everything is going to come from the drawing. So on this slide here, you can see this is an example of what a typical drawing might look like. So in the top right corner here, we have like a view from kind of an angle, kind of from the side. This is what we'd call an isometric view. This is what the 3D object looks like, right? It's a little block. It has little protrusions on the top and the side, and there's a hole that goes through the middle. And so it's not the most complicated object out there, but it's not the most straightforward thing, right? Even I have trouble describing this object. If I just told you to make a block that has a little protrusion on the side and on the top and one hole in the middle, you really wouldn't have any idea where to start. And even if you tried to make that model, it wouldn't be exactly the same as the one I had. So where the drawing comes in is that it shows you all in 2D, all on a piece of paper. It shows you multiple different views of the object, and it has all of the dimensions that you need, so that you can look at this drawing and everything that there is to know about the object, it's all on that piece of paper. So if you take a closer look at this drawing here, let me zoom it in for you. We can start breaking down what's going on here. So there's three main views that we have of our object, right? We have this one here, and this one here. And so we'll start here, for example. This is what the object would look like if you were looking perfectly straight down on it. So you can kind of look at the one in the corner, try to connect the two together. This little nub corresponds to this here. So actually, this is a bottom view. We're looking at this object from the bottom. This one would be a view from the front. So if you laid the object right on a table or something, and you just got down, had it right at eye level, and you looked at it head on, that's kind of what you would see, like a little olive shape. And this one is a view from the right. So again, you set it down, and then you come in from the right and you look at that object. This is a view of what that would look like. So yeah, when you first start looking at these, it's a bit to wrap your mind around, but once you get used to it, it'll be a lot easier. So I'll go over now a few ideas that'll hopefully make this a bit clearer. The first thing being the idea of what we call an orthographic view. So in that drawing, I said there are these three different views, right? One we're looking from the front, one we're looking from the side, one we're looking straight from the bottom. And so those you can kind of think about as orthographic views, right? We're looking at it from one side of the part, either the front, the back, the left, right, or the top or the bottom. And you can actually do this in Onshape too. Whenever you click on one of these faces on the navigation key, take you to the orthographic view from that direction. So for example, on a drawing, the top view of this chess rook would look something like, it would look something like this, right? It would be a circle with these four little, I'm not sure what to call them, kind of trapezoid arc shapes on them. This little symbol, this is what you'd see in the top view of a drawing of my Chesterbrook. Then the front view, if I were to make a drawing of this, again, the orthographic projection from the front, when viewed from the front, you get this kind of shape. So we have our two cones here, a little rectangle here on the bottom, another rectangle here. That's our front view. And in this case, the right view basically looks exactly the same because it's more or less rotationally symmetric. So when we have a drawing, almost always we're going to use these views, right? We're either going to have the front, the back, the left, the right, and the top or the bottom, instead of, say, a view from any weird angle like this or this. You're almost never going to see a drawing where the model is given some weird angle like this, because it's hard to create the dimensions and convey accurately which lines are straight, which lines are parallel. It's always going to be either front, top, or right. And one other property of a drawing is that usually you're just going to have enough information on there to fully describe the part. So again, going back to this drawing, what that means is that technically I could add a lot more dimensions to this drawing, right? I could tell you the length of this line, this line, this line, this line. I could add one of these dimensions for every single line segment that's on this drawing. And that would just as completely fully describe the shape. You can imagine if I did that, it would be really cluttered and it'd be really hard to read because there's so many dimensions everywhere. So whenever people make drawings, they usually try to limit the number of dimensions they use while still having enough information to fully describe everything. It's kind of like how when you're dimensioning sketches in Onshape, you don't want to add too many dimensions or else you start to have like conflicting rules, and that can over constrain your sketch when everything turns red and it stops working. So it's a similar idea. You don't want to have too many dimensions. You just want to have precisely the ones that you need and no more. All right. Here's a few more like things that can help make things clear. In most drawings, you'll see a few different line types. So it's easy to get confused when you're not familiar with these. So I'll just say them now, and you can always come back to this slide and look at it again. Most commonly, solid lines will define the visible edges of a part. So whenever you look at, let's take this thing, for example. Let me quickly model what that would look like as a 3D model. It's very simple. It's just going to be forgive me for not fully dimensioning that, but for the sake of demonstration, let's say we have a 3D object like this, right? Looking at the 3D model, you can pretty clearly tell what it is. It's a block, it's a square block, and there's a hole in it. So hopefully everyone can picture that this could be an object in real life, right? Like you take a block, you put a hole in it. So now how do we communicate this in a drawing? If you're listening to what I was saying, you know, we have to use one of our orthographic views, one or more of our orthographic views. So you have our top view, which is going to look something like this. And this is basically the sketch that I created, right? It's the rectangle and the circle in the middle. So yeah, that'll be the first part of our drawing. The second part of our drawing though, when I look at this object from the front, I know that there is a hole going through the object because there is, I saw it. But when I look at it from the front, there's no way for me to see that there's a hole there. If you just showed me this right now, if you just looked at my screen right now, you had no context, and I asked you to identify what this is, you'd probably say it's a cube or something because that's all you can see. There's no reason for you to know that there is a hole in the middle. And that's kind of a problem because when we have drawings, we need to communicate everything about the object, including the fact that there's a hole in it. So what we do is we use a different kind of line. In our drawing for the top, all of these would be done with solid lines. We'd have a square and a circle all in these solid lines. But when we do our front drawings, we're going to have what we call hidden lines. So these are the dashed lines. You can see here the finely dashed line. That is what we might call a hidden line. And those indicate edges of a part that are behind something else or for some reason can't be seen directly. So right now, hopefully you can see I've highlighted my hole, right? And you can see these orange edges of the inside of my hole. So imagine those are my hidden lines, right? In my drawing, I would have a big rectangle here with solid lines. And then these two orange lines would be my dashed lines, or my hidden lines. And when I show you this, now you can kind of tell that there's something else going on here. It's not just a solid cube. There must be a feature inside that follows these orange lines. And that tells me, oh, it must be a hole. There are a few other kinds of lines. There are actually a lot more, but the ones that I'll use here, there's a center line. And so that's this one here, where there's a long and a short, long and a short. This line indicates that there's symmetry. So whenever I put these lines, all I'm saying is that you can treat it like a mirror, right? Everything, in this case, everything on top is the same as everything on the bottom. And this can be useful because sometimes maybe you only want to dimension half of your drawing. And if the other half of the part is just the mirror image, then there's no need to dimension everything twice. You just dimension a half of it, and then you put a center line there to indicate that the other side is exactly the same, just mirrored. And another one is the break line. So let's imagine that I have a really, really, really long part, right? Some crazy aspect ratio like this. I have this long bar and I want to make a drawing of this. What I could do is just put this entire thing on my piece of paper, but what you can imagine is most of this, it would look really bad, right? You can hardly tell what was happening because it's so thin in comparison to its length. So just having this on a piece of paper, it doesn't take up the whole page, and it's really hard to see, for example, what the dimension from here to here would be because it's so squished down on your piece of paper. So what you can do, how you can represent that, let's say my bar is horizontal, my screen is my piece of paper here. What I can do is just add these break lines. And what that's saying is that I just didn't include everything that's between this end and this end. It's all the same thing, just ignore it. And here's the interesting stuff, right? For example, if you ever graph something in math and your graph starts at like 100 for 100, you usually don't start at 0. Right? Like if this is 100 and all your points are like this, you don't want to create a graph like this. What you would probably do is something like this, and just say this is 100 and my points are like, yeah, Okay. Yeah, maybe you've done that in math class before, where you just like put that little jagged line to indicate that there's a break, right? Instead of going all the way from the bottom to the top. Anyway, those are the lines. And let me know at any point if you have any questions about things I'm talking about. Feel free to chat or say something. All right, last thing, and then we'll do like a little practice activity to help you get the drawings, and then we'll introduce our first mini project. So in addition to lines, the other things that you might see on drawings are special views that give you more information about what the object is. So we won't use most of these in this class, but these are very common. So if you're ever looking at drawings online of other parts that maybe you're interested in trying to make, it's very likely that you might see some of these. So section view, that's when you might have a dashed line like this, and it's usually labeled with letters like AA, BB, CC, and so on. And those show you what's happening inside the part. So you can imagine if I have my cube with my hole in it, what a section view implies basically is that you take a knife and you cut the object right along that line, right? If this is a cake, line AA is where you take your cut. And then section view AA, the thing labeled section AA here, that's now when you're looking inside at the face of the cut you just made. So here you can see the parts that are hatched and shaded here. These are solid material. And then in the middle, that's where our hole was. There's nothing there, so it's not shaded in. A detail view, that's exactly what it sounds like. It just zooms in a small portion of the drawing so you can see it better. And that can be helpful, especially when the object is a weird shape. So, or there's something important in a very small area. And the auxiliary view, which I usually try to include when I make a drawing. And that's just a view from an angle. That's not like your front, back, front, bottom, top, left, right. Just from any angle that gives the reader a good idea of what the 3D object looks like. All right, so that's all I have to say about drawings. Now I want to do a quick activity. Before we do that though, are there any questions about drawings? Okay, so we're going to do another activity. So I want you to either pull up the pen and paper that you have next to you, perhaps, or just open up a program on your computer that lets you draw. And I want you to create a drawing of this object here. So from the image here, you can see it's a tube, right? Hopefully it makes sense what it is in 3D. And my first question for you is, how many orthographic views do we need to fully represent this object, right? When you have front, bottom, front, back, top, bottom, left, right, there are 6 possible views that we could include. But remember, we only want to include the minimum amount of information that you need to understand what the part is. So what is the minimum number of views among the options of front and rear, top and bottom, left and right?
2.
Sure. And which 2?
Because you can't see the other side of it. Maybe you turn it around, and that'll allow you to see the left side. Depends on what angle you're pointing it at. And so then you see both right, left, front, and. But you won't be able to see down, and then you point it down.
Sure.
Is the actual one 1?
So yeah, and so when I say like views, think back to the navigation cube here. Specifically, if I had my object, right? Let me, in fact, give me a second and I'll model that. We have our circular tube, so our outer diameter, inner diameter, and I'll just extrude that. So when I talk about a view, what I'm saying is that we have 6 options for views, right? And we can include 1 view, 2 views, all the way up to all 6 views. So this is what our views look like. This is my front view. This is my top view. This is my bottom view. This is my right view. This is my back view. And this is my left view. So of those 6 views, what's the minimum number of those views that I need to represent this object? Or in other words, like how many of those views were exactly the same and can't be told apart?
Left in, right.
Right, so left can be one of them, and then we probably want one of these views, and those are the only 2 that look different, right? Since this view looks exactly the same as this view, looks exactly the same as this view, and this view looks exactly the same as this view. So yeah, your first answer 2 was correct. The only 2 views that we need are one of the views that look like this and one of the views that look like this. And so given that, now it kind of, maybe I gave this away a bit, but do we need any kind of special lines in our drawing, in any of our views? And what kind of lines do we need to use?
Hidden lines?
Yeah, and what feature, what aspect of this thing?
The back one.
Right, so when you're looking at it from this view, you have no idea that there's a hole inside of it. So you do want to indicate that. So what your drawing would look like is probably, you'd have your front view, which is a bit of a rectangle. And you have your 2 hidden lines. I'll just do something like that. And then we have our top view, which would look something like that. And, oh geez. That would be something like that. So a drawing of my little tube here would be something like this. Are there any questions about anything so far? Okay, hopefully. Right, I'm sure you got the idea. So yeah, hopefully you see that this is a pretty powerful tool. Now you don't need everyone to have their computer out in order to show them what a 3D object looks like. You can use these tools to create drawings, and then people can look at these drawings and fully recreate the 3D image or the 3D object using their CAD programs, or maybe they're manufacturing it in real life. and they're making it out of like a block of metal or a block of wood. The drawing has all the information, right? That's the key idea. And so with that, since there are no questions, let me introduce our first project. It's going to be a really quick project. We're going to finish it at the end of next week. And that is modeling a universal joint. So I think I have this assembly left over from a previous class. Let me see if I can find it. Here we go. And I believe everyone in the class has some, I guess one of you might not have used Onshape before. So I'll explain with a bit of context. This is what we call an assembly, which is when we take multiple 3D parts that we modeled and we combine them together into a single area.
I have a question.
Yes.
You're allowed to take level 2 before you take level 1?
I don't really know about that.
Because like, didn't we learn that in level 1?
Yeah, I'm just going to say things like this because, you know, like not everyone has the same CAD background. Maybe some people have some CAD experience already, so they just come straight to this class. But they also might have experience in like different CAD programs, which are slightly different. So maybe if they're used to Autodesk, Inventor, or Fusion, or Tinkercad or something, it's good to just go over the basics in Onshape as well. In any case, it's also a good refresher for anyone who was in the level 1 class. So this is an assembly, and the idea is you take all the parts that you made, and then you define a set of rules for how they're allowed to move with respect to each other. So let me just animate this guy for you. Hopefully it still works. That'd be nice. Whoops. I want to animate this one. Okay, let me just animate this one then. There you go. Okay, hopefully you can see that through the Zoom lag. Actually, the animation is a bit broken. It's kind of like jumping back and forth instead of smoothly rotating, but you can hopefully see what it's doing. And that is allowing rotation to be transferred between two shafts that are not coaxial.
And aren't you going to use the... Never mind.
Right. I can also show you some U-joints in real life. So these might be used on some like vehicles. Your car probably doesn't use a U-joint, but a lot of like ATVs or UTVs might have U-joints for their drive shafts. So on your car, when you're going from like the transmission to your wheels, those usually aren't in the same position because you have a suspension on your vehicle. And those mean that they're going to be offset and variably angled with respect to each other. So you're going to need a U-joint you're going to need some kind of joint that can transfer rotation between two shafts that are not collinear. You might also like maybe played with toys that like Legos or something that have U-joint like pieces. Maybe I can find a quick video. Okay, maybe not. Go back. All right, so you can see here it's a real U-joint, and you can see that the rotation from this shaft and this shaft are successfully coupled, even though they're pointing in different directions. Anyway, that's a project. If you want to learn more about U-joints, you can do that on your own. But this is going to be a very simple model of a U-joint. There's 3 unique parts. So if you take a look at the completed assembly, we have our stand here. That's the base that it's all resting on. We have our clevis, which is what I'm calling these 2 like fork-shaped objects, like tuning fork-shaped objects. And then there's a thing in the middle, the thing that looks like a little plus sign, which I'm just going to call the bearing cross. So called because in real life, they would have bearings inside of them to let them spin. In our model, they don't. So it's a bit of a perhaps inaccurate name. And so now for the last 20 minutes of class, hopefully I will demonstrate how you can use a drawing of a part to accurately recreate a 3D model of the part. So take a good look. Here's a drawing. It's the same stuff that we saw and the same ideas that we were talking about before with our tube and our block with a hole in it. This drawing contains all the information you need and no more for how you can create a clevis. So I'll kind of go a bit quickly because I want to finish this demo before the class ends here. But I was asking myself, what shapes do I see? Here in this top view, I see a rectangle and another like smaller rectangle here. So I'll start out with that, right? And since you probably have Onshape up, you'll want to create a new document. Just call it whatever you want. Something that you'll remember and be able to access later. And as we do, whenever we intend to create an assembly in Onshape, I usually like to keep all my parts together in the same document. So as a refresher, this is how you do that. My first part is my clevis. And then to add new parts, don't go back and make a new document. Stay here, hit the plus sign, and you can create Part Studio. And that just creates another Part Studio right there, which makes it easier to find things when you're doing your assembly. So I'll just make these in advance, but I already know what I need. And my assembly, of course. Right, back to the clevis. Go to my top view. And I'll start out by making this part of the little fork. Right, so I know it's a rectangle, and I'll start out with being 2 inches in base and 1.5 inches in height. So I'll create a sketch and I'll just use the line tool and carefully place my lines to get those free relations so I don't have to make them later. Right, this is a basic shape of my fork. And now I'm just going to create a few rules to help me, the things that I know that are true about it, right? So across the middle here, what kind of line is this?
A straight line?
Yes, it is straight. And what does it indicate? This dash short.
The line of symmetry?
Yes, so I know that this part is symmetric about that line. So I know this part has a thickness of 1/4 inch or 0.25, and then therefore this one must also be the same thickness. So basically I can start using my relations, in particular the equal relation, given the things that I do know about this object. So I know that this is equal to this. I guess this should be equal to this. Great. And now that I added those relations, whenever I try to drag it around, it stays in a symmetric way. You of course don't have to do these, do it exactly the way I'm doing it. You can also like dimension it or something, but I'm just showing you.
How do you make it so that it only moves one way?
I took my equal relation and I just made everything equal that should be equal to each other. So this guy, and I'm sure you can think your way through it. Now this guy from the drawing, I remember it's 2 inches. This guy I remember is 1.5 inches. That just corresponds to the numbers in this drawing. I didn't make anything up. It's all real. It's all there. And this was 0.25. Last thing, how thick is this part? I can see this part is also 0.25. So I'll go ahead and do that. And you can see already that's my sketch fully defined right there. Thanks to the relations that I used. If things are still blue, the advice that I always give is click on the points that are blue and try dragging them around, see how they can move and get rid of that freedom, right? The only reason things are blue when you've dimensioned everything is because they still have too much freedom. So you need to use your relations to get rid of that freedom by adding more rules. All right. Don't worry too much if I'm going too fast. The class is recorded, so you can go back. I'll stick around for a few minutes after class to answer questions, but I do want to get this whole demo done, so I will go through it a bit faster than usual. So next, I'll just extrude it. And the question is, how deep do I extrude it? And the answer to that is also in the drawing. This is my top view. And so you can imagine this top view kind of looks like the sketch that I was trying to make. So if I extrude it, I'm going into the third dimension, right? The sketch was in my 2D piece of paper. The extrusion comes out of the paper. It's in a different direction. So the answer to that question, how much should I extrude it by? It's not going to be found in this view. It's going to be found in this view. And so here, this 0.5 inches here, the height of the fork when it's lying flat, that is how much I need to extrude it by. So I'll just type that in, 0.5.
Not
and
connected.
There we go.
Mine's not connected.
Yeah, Onshape is like a web application, so yeah, if your internet is spotty, you might have some issues, but hopefully you're still with us. All right. Next feature, I'm going to model the little hole that's in the side of the fork, right? You can see them here and here as well. And so that hole I know is 0.25 inches in diameter. And it goes through this way. So I want to stay looking at this side view now.
It's not, wait, no, never mind.
So I want to look at it from this view, where I'm looking at it kind of like at eye level on the table. And I'm going to create a sketch, therefore, in my front plane. And in my front plane, the feature I'm trying to make is a circular hole. So the sketch that I make will be a circle.
There's still one that's not, that's still blue. I don't know how to change it.
Right, so I would just try to drag the blue points around, see how they can move, and try to analyze what degree of freedom that you need to get rid of. It's not always easy, but the more practice you get, the better you'll get at it. All right, so in terms of the location of this hole, I know first of all that it's located 3/8 of an inch or 0.375 inches away from the edge here. So I'll create my first dimension from the center of the circle to this line. And I'll just call that 3/8. Whoops. Yeah, 3/8. There we go. And the second thing is, where is it located up and down, right? And it doesn't actually say so on the drawing, but again, we have one of our center lines here. And so the whole is, I guess it's not explicitly stated, but we'll assume here that the whole lies on the center line, so it must be centered. So there's actually a pretty cool way that I can do this using just a relation and no dimensions. If I use my horizontal relation.
Mine doesn't work. The extrude just goes into the extrude just follows up into the it goes into my next sketch. I can't really make another sketch. Like it doesn't work.
I'm not sure exactly what you're describing without looking at it, but in a few minutes, if you haven't gotten it, I can help you with that. All right, what I'll do here is create a point on my line here. And what I can do is make it a midpoint. So again, that's one of our relations, but Onshape can create it for me automatically if I try to create the point close to the middle. You can see that orange square there. So if I plot my point there, you can see it starts out black because it is fully defined, because it is a midpoint of a line that's already fully defined, or rather a line that's like, that exists outside of my sketch. And then what I'll do is I'll take that midpoint that I just created and the center of my circle, and I'll make them horizontal with each other. And so now the center of the circle turned black because its X position has been set by this dimension, and its Z position has been set because it's horizontal with the midpoint of this vertical line. And the last thing is that dimension. And to create the whole, as you recall, you can use the same extrude tool. But instead of the add function, you use the remove function. I'll just tell it to go through everything. So not blind, but through all. And that creates my whole. All right. I'll pause here to take a quick question or two. If you're still having an issue, let me know.
Mine doesn't really work. Like I can't.
Okay. Here, do you want to show? That's probably the best way to figure out what's happening.
Okay.
All right. And what's...
Basically, when I press sketch, it just keeps this in it.
What do you mean?
Like it keeps this, the sketch one excluded from it.
All right, sketch one, or the first extrusion should still be there, right?
Then how do you create the other thing?
So yeah, in your sketch dialog box, right now the sketch plane is top plane, right?
Yeah.
So hit X on top plane in your dialog box. Or okay, you can also close it. So you want to, for your sketch plane, you want to select the side face of your extrusion, not one of the default planes. So yeah, instead of right plane, you want to, so go back to that dialog box. You don't have to close it every time. You can just like hit the small X next to where it says sketch plane. But yeah, and so zoom in and you can click on the 3D object itself, or you can just select your...
This one?
Not that one, kind of rotate your view a bit. Yeah, so you can actually just use your front plane too. That should work.
But that just created a sketch on this.
Right, that's what you want.
But now how do I do it?
You can just create your circle, yeah.
Huh?
You can just create a circle. So yeah, this is not the right plane. So yeah, instead of Xing out the whole thing, you can actually just X the small X in the sketch plane section. So
Can't see it. I don't know where it is. I can't see it.
okay, go to the dialog box,
What dialog box?
or the one that's the sketch 2 interface, right? Yeah, that little X. And then you can go, now you can select front plane. And you should be able to sketch a circle on the side of your clevis there.
Where do I put it?
Yeah, and for that you can refer to the slides, which have the drawing. It's halfway in the middle, up and down wise, and it's 3/8 of an inch from the edge. I think your extrusion is a bit short though. It should be 1/2 inch tall.
What do you mean?
It seems like your extrusion is thin, just based on the ratio. Right, like what was it, the depth of your extrusion?
0.2.
Right, so it should be 0.5.
Oh.
Per the drawing, but it seems like you're good to go. If you could return the screen share.
Well, like I don't like. How do you put it in the center?
If you could return the screen share, I'll quickly show you that and then move on to the end of the demo. All right, I'm zoomed in. Jeez. Am I? Or maybe not. Okay, I think we're fine. All right, so for this sketch, what I did to put it in the center, I created my midpoint here. So I took my point tool, plotted it such that I had that little box highlighted, and that just creates a fully defined point automatically. And then I made the center of my circle horizontal to that point.
Wait, what? That doesn't fully define it though.
Right, so the other part is it needs to be 3/8 of an inch from the edge, and the diameter needs to be 1/4 inch. And all of this is from the drawing. So there isn't any guesswork or making things up like there were for previous ones.
And then this
Now on,
the circle is. Oh no, wait, never mind. It was wrong. Okay, I did it, but why does my circle look so big?
you can go back and look at the drawing and try to figure out which dimensions are off. Last thing we're going to do is make a third sketch. So this one, in my case, this can be on the right plane, or we can go directly off of this face if you want.
We have to do it on both sides, right?
You can just do it on one and extrude through all instead of blind, and it'll go through everything.
I put through all and it's doing nothing.
You might have to flip the direction. Is it going?
Yeah,
Also, are you on remove?
Going through, but one side is too long. It's like really weird.
Not quite sure what that means, but
like the cylinder, like the shape, like it's through one of the sides, but on the other side it's peeking out. They're coming out.
Are you adding material or removing it?
No, I'm in the extrude.
Right. So in extrude, you want to have it on remove, right? So that it's cutting.
Like it's like one side is popping out.
We can take a look in a bit.
So I can share my screen.
I'm going to finish the demonstration while we're recording so that you have something to refer to later. Again, in this case, the post of the clevis, this part here, it comes out of the center, right? And I know that because I know it's a circle based on this view, like I know it's a cylinder. And then I also observe that it has a line of symmetry from both the top and the side view. So that suggests that the axis of the cylinder goes through the center, right? The diameter of this circle, I know from this view that it is 0.375, and the length of the post I know is 3 inches. So to center the circle properly, I'm just going to make 2 construction lines. Hopefully you remember when we're creating lines that aren't actually edges of our parts, we try to make them construction lines. And then I will use my relations to make them respectively horizontal and vertical. So now the center of the circle is black. It's fully defined. I'll give it a dimension, 0.375. That's my sketch. And I'll extrude to a length of 3 inches. Whoops, guess it didn't take. To a length of 3 inches. Wow, I'm getting some lag here. Hopefully that is not a bad sign. All right. So that's the end of the clevis. Basically, just an extrusion of this fork shape, making the hole and making this post here. And that's everything there is. Hopefully that gives you an idea. Pardon. Hopefully that gives you an idea of how you can use these drawings to create a 3D model like this. All the information I used, everything was in the drawing. I didn't have to come up with anything by myself. All I did was look at the drawing, find the numbers, and do that myself in Onshape. So I'll quickly just wrap up the class. I know it's the end of the class, so for everyone, the closing remarks. By next week, this will be your first homework assignment, but by the next class, I want you to finish the stand and the clevis. So those are the other 2 parts. And the slides are in Google Classroom, so make sure to join the Google Classroom. If you haven't, these are the week 2 slides, and so you can open these up yourself. And if you go down to the bottom here, you can see these drawings for yourself. Next week in class, I'll take some time at the beginning to answer questions about modeling. So if you had any trouble with modeling these 2, we'll go over it together at the start of the next class. But we are going to assemble it next week and wrap up this little mini project, which is more of a primer for how to read drawings.
Wait, what is the homework?
It'll be these 2 parts. So making this cross and making the stand here.
But I don't know how to make my clevis.
And at the last slide, if you refer here, here's some helpful hints that I put together for the things. So for the bearing cross, one thing that can help you is to make the center of the part, the very center here, the origin of your your part. And all right, so we are past time. So if you need to go, that's the main thing to take away. Today we learned how to read drawings, and the homework is to make these 2 parts. If you need to go right now, you're dismissed, but I'll stick around for a few more minutes to go through a few hints, and that may, I guess that may be in the recording, so you can also come back. All right, so goodbye if you're leaving.